This video is about equilibrium. In this video, we will learn how to find equilibrium concentrations. Essentially, we are finding the concentrations of the reactants and products at equilibrium. So looking at the equation here, I think we're quite familiar with it. It's the Haber process. So the question gives us both the number of moles of the reactants and products, as well as their volume. So let's break down the question and information given to us. So in the question it says that there are 0.5 moles of nitrogen, hydrogen, and ammonia. So here I've highlighted all the important information for you. They are then put into a flask, which is 2 decimeter cubed. Then it goes on to say that the equilibrium concentration of nitrogen at the end was 0.2 moles per decimeter cubed. The question is then asking us to find the equilibrium concentrations of hydrogen and ammonia. So we already have the equilibrium concentration of nitrogen. So when we need to find the equilibrium concentrations or when we're working with equilibrium concentrations at all, we need to use the ICE method. So this is the concept we need to remember. I means the initial concentration, C stands for change, and E stands for equilibrium concentration. So in this case, we're looking for the equilibrium concentration. So first, let's find the initial concentration. So this is given to us in the question. In order to get the concentration, we can use this formula, moles over decimeter cubed. So in the question, it says that there are 0.5 moles in 2 decimeter cubed. So we take 0.5 moles divided by 2, and we get 0.25 moles per decimeter cubed. So let's fill that into the table. Alright, then the question gives us the equilibrium concentration of nitrogen gas, which is this one right here. And so if the initial is 0.25 and the equilibrium concentration is 0.2, means the change is 0.05. Now, to find the change in hydrogen and ammonia concentrations, we need to look at the molar ratio of hydrogen and nitrogen and ammonia to nitrogen. So why nitrogen? It is because we already have the full information here. Its initial concentration and its change as well as its equilibrium concentration. So let's take a look first at hydrogen. The molar ratio of nitrogen to hydrogen here is 1:3. So if the change that happened in nitrogen is 0.05, the change that will happen in hydrogen is 3 times that. So 0.05 times 3 is 0.15, which means its equilibrium concentration will be 0.25 minus 0.15, and you'll get 0.10. The concept for ammonia is the same. So the molar ratio of nitrogen to ammonia is 1:2. So means the change of ammonia is twice the amount of nitrogen. So if you take 0.05, you times 2, you will get 0.1. So the change is 0.1. However, instead of taking 0.25 and minusing 0.1, you add 0.1 because it is a product. So the equilibrium concentration would be 0.25 plus 0.1, so you'll get 0.35. So there you go. Here are your answers, and do not forget your units, mole per decimeter cube.